Good day to you all. I am Donald Mjonono from the CIBA Research Group at the University of Cape Town. The title of my MSc project at the Center for Bioprocessing Engineering Research is Reclaiming Mine Areas through the Coal Disposal of Coal Discards and Coal Fine Waste to Facilitate the Prevention of Acid Rock Drainage. To put into perspective, coal discards are generally acid-forming coarse particles, which form load-bearing structures with large voids when deposited, and the fine waste are environmentally benign, acid-neutralizing materials with potential to counter acidity formed. Through coal disposal, a structure with improved load-bearing potential and decreased voids is formed, such that oxygen and water ingress to the sulfide mineral surfaces is prevented. The problem with this technique is that at increased bed cross-sectional area, particle interlock is decreased to result in unrestrained permeation of oxygen and water to the underlying coal discards. Acid rock drainage is generated as a result, and that's where I come into play. So, to prevent the oxidation of pirate-bearing coal discards, I considered engineered coal disposal of coal discards and fine waste at corresponding dry mass ratios of 3:2 and 2:3. My objective was to minimize voids, increase packing density, and improve bed structural strength. Static acid-base accounting and net acid generating tests were used to establish the acid generation potential of the coal waste components which were sourced from coal mines in South Africa. The coal discard sample with 2.16% total sulfur was shown to be potentially acid generating. The sulfide lead fine waste was non-acid forming, and the commingled samples were uncertain. Biokinetic tests, which incorporate the influence of microbial activity on ARD generation, were therefore conducted over 120 days to resolve the relative reactivities of the P components and mixed samples. Confirming the acid-base accounting results, the coal discards was acid-forming. All the fine waste samples sustained neutral conditions for prolonged periods. However, acidic conditions manifested in commingled systems once the neutralizing capacity of the fine waste was depleted, thus indicating the practical implication of coal disposal strategies. To aid restrictive permeation of natural oxidants, I developed all packing arrangements using workability and packing behavior tests such as slump, packing density, and compressibility. For compressibility tests, stress was applied at a constant loading rate of 5 milliliters per minute, and the corresponding strain and time data was plotted in real time to assess the particle settlement and consolidation behavior. By analyzing these geotechnical results, packing arrangements showing decreased voids ratio, low slump, and low compressibility were selected for kinetic column testing. In these kinetic column tests, a mediated framework characterized by aggressive leaching conditions was established to validate the geochemical and geotechnical results as a means to develop protocols for ARD prevention at pilot scale. Acidified water connected to pH 2 was continuously introduced into the blue and white columns of diameter 0.19 and 0.32 meters respectively for 120 days. Effluent discharged from these columns were collected and recorded at 48-hour intervals and analyzed for pH, redox potential, ferrous ion, total ion, and sulfate concentration. Unlike wet packings, in which contacting of coal discards with moisture likely led to early onset of oxidation reactions, dry-assisted packing approaches resulted in low flow rates and near-neutral conditions, with increased effluent flow rates manifesting in blends beyond day 70. For multi-layer cover configurations, functional migration of particles to vacant voids likely transpired to maintain impermeable barriers within the fine waste layers. At increased scale, the non-uniformity of particles in blended systems was amplified, resulting in high effluent discharge rates, whereas structural stability was maintained in multi-layer systems as a result of moisture retention layers. This study showed that, with assisted packing, a long-lasting geochemical and geotechnically stable structure is formed, as particles are closely packed, voids are minimized, and the incidence of sulfide mineral oxidation is decreased. For effective ARD prevention, a dry cover system composed of multiple layers of coal discards with fine waste is therefore recommended when conducting pilot scale studies. Advantages include the simplicity of construction, high load bearing capacity, and improved moisture retention properties. Thanks for watching.